Hi everybody, this is set 96 on page 656. This lesson is about estimating angle measures and distributive property with algebraic terms. Okay, when we talk about estimating angle measures, we are looking at trying to estimate angles when we see different measurements. For example, if you see an angle and you know it's not a right angle, it might be a little smaller, a little bigger, we can estimate what the measure of that angle is by using some of the skills we're going to look at today. And we're going to use a clock, or somewhat of a clock, as a mental image to help us figure this out. We know that in a circle there are 360 degrees. If you are pointed this way and you turn completely around in a circle, you have turned 360 degrees. So a full circle going around is 360 degrees. We're going to equate that to a clock. If you had a minute hand on a clock and it went completely around the clock from 12 back around to 12, that's a 360 degree turn, just like a full circle. So when we look at that, we can do some dividing to figure some things out about a clock. For example, if you had the minute hand pointing towards the 12, and you had another hand pointing towards the 2, we know, of course, that's 2 o'clock. But if somebody said, well, how many degrees is this angle right here? Well, we can figure some things out when we compare degrees with measurements on a clock. And what we mean by that is, if we know that there are 12 divisions, 1 through 12 on the clock, if we took 360 and we divided it by those 12 divisions, we would end up with 30 degrees. So that means from 12 to 1, 30 degrees, 1 to 2, 30 degrees. And what that means is, if you had one angle line here and another line here, that's 30 degrees. Another one, another 30 degrees. Another one, another 30 degrees. So each number is 30 more degrees until you complete 360. So if we are pointing at the 12 and at the 2, this measure covers from 12 to 1 and 1 to 2. From 12 to 1 is 30 degrees, 1 to 2 is 30 degrees, so 30 and 30 is 60. So we know that this is a 60 degree angle. Okay, another way we can also figure that out is if we look at the individual tick marks, because obviously clocks are not always just on an exact hour. So if we look at the individual tick marks, we know that there are 1, 2, 3, 4, 5 from 12 to 1. There's 5 tick marks. And likewise, we know that if we went all the way around the clock for an entire hour, that would be 60 minutes. So if we took 360 divided by 60 little individual divisions, if I put them all on there, we would end up with 6 degrees. And what that means is, for every minute, for every 1 minute, that equals 6 degrees. So let's say, for example, you had, let's say our clock was on, let's say if it was on between 12 and it was on, let's just do here. And I'm just making this up. I know that's not a precise time. But let's say one hand was here and one hand was here. Well, this is 1, 2, and 2 more. So that would be 5, 10, 11, 12. That's 12 little tick marks from here to here. So we could take our knowledge of this. Each little mark is 6 degrees. So if 1 minute is 6 degrees, 12 minutes times 6 degrees each would be 72 degrees. So this is a 72 degree angle. And so you can equate what you know about degrees and divide that up among the divisions that are already on a clock to actually figure out the measurements of that. So how does that apply to our lesson? Well, let's get started with example 1, and we're actually going to look directly in the book because their drawing is much more precise than what I can draw on the dry erase board. So we're going to just look straight at the book for example 1. All right, example 1 here says, estimate the measure of BOC in the figure below. Right, B would be here, this is B, O is here, and C is here. So if you want to measure this or figure this out, we are looking at BOC. So we're looking at this little angle right there. So we don't know exactly what that is unless we use a protractor, which you should also have to find the exact measurement. But to estimate that, we can try to just use the skills that we know. Now here's how I would figure that out. If you kind of turn your book and compare where a right angle would be, and it's a little bit difficult to do, you could see that if we turn this and try to make this a right angle, it would have to, the line would have to go here. So this is obviously less than 90 degrees. So I would estimate it would probably be around 75 degrees, a 75 degree angle. That would be my estimate, just looking at that. Now, if you take your protractor and measure it, you should find that it is actually a little bit different, because our estimates usually aren't exactly right. They use the example here on the next page of lining that up on a clock. And if you see, they lined it up. They have the C part there, and they have the B part over there, which is about what we had on the board. So they found that it went to the 12th minute after the number 2, and they multiply that by 6, and they got 72 degrees. So the estimate of this would be that it is a 72 degree angle. Now, when they use a protractor, and if you take your protractor and line it up on that, you will see that it is exactly a little bit larger. Here's the 0, counting upwards, it goes up to halfway between 70 and 80, which would be a 75 degree angle. So the estimate, they would estimate using the clock method, would be a 72 degree angle. The actual measure would be 75. So that's pretty close. And the difference, of course, was the C part, and that's 75 minus 72 is 3 degrees. So that kind of shows you how using a clock and your knowledge of angles and measurements of angles can help you get some pretty accurate measurements when you're just estimating on your own. All right, let's look at the second part of this lesson. All right, the second part of this lesson is about the distributive property with algebraic terms. We've seen this before. This is talking about the distributive property, which means when we have A times B plus C, it can also mean AB plus AC. And what that means is you take the first term or the first letter and you multiply it by the first one in the parentheses. Then you add and you take the same first letter multiplied by the second one. And that's what's illustrated here. So A times B plus C can also mean A times B, which is this here, A times B plus A times C, A times C. So what does that look like in practical math? Okay, if we took, let's say A was 2, and B was 1, and C was 3. If we work that out, of course you can say 1 plus 3 is 4, 4 times 2 is 8. We think that's our answer for that. Using the distributive property, we would say 2 times 1, which would be 2 times 1 plus 2 times 3. And if we work this out, 2 times 1 is 2, of course, and 2 times 3 is 6. 2 to 6 is 8. So they both get the same answer, and that's what the distributive property means, is we can use this method or we can use this method and we get the same answer. In algebra, we are going to use, they're going to give us problems that look like this, and we need to use this method in order to put them in correct algebra form. So in example 2 on page 659, that is what they are showing you. So in example 2, we have A, we have B, we have C, and we have a D, which is very lovely. All right, let's look at A. A says 2 times x minus 3. So what does that look like in algebra form? We're going to say 2 times the first minus, then 2 times the second. Okay, so 2 times x, we don't know what x is, so all we can do is just put 2x, put them together. We have a minus here. 2 times 3 is 6, and that is your answer. 2 times 6 minus x. This is correct algebraic form. All right, B says negative 2 times x plus 3. All right, negative 2 times x is going to be negative 2x. You simply put them together. When there is an unknown variable, all you can do is put them together. Okay, now this is where it gets a little bit different. If we have negative 2 times positive 3, we have to think of the plus as a positive, and we know a negative times a positive is a negative. Therefore, we're going to put negative or minus there. 2 times 3 is 6. So this would be our answer here. Okay, C says negative 2 times x minus 3. All right, again, we do our negative 2 times x, which is negative 2x, and then negative 2 times negative 3. You have to think of the minus as a negative. Negative times a negative is a positive. 2 times 3 is 6. So that's how we get that one there. All right, and d is x times x minus 3. All right, and this one we're also going to do x times x. Now, x times x does not mean 2x. That would be adding 2 x's together. We're not adding, we're multiplying. So 2x would be x squared. Okay, this is a negative there, or minus, so we keep that. X times 3. You could put x3, but correct algebra form, you always put the number first. So it would be 3x. And that would be the simplest forms that you can put these expressions in. Okay, let's look at example 3 very quickly here. It is very similar to this, but uses slightly more complex terms. All right, example 3 says x squared plus 2x plus 3 times x minus 2. Okay, first thing we have to do is we have to use the distributive property to put that in correct algebraic form. Okay, I'm going to bring these down because I haven't done anything with them yet. Now we're going to do 3 times x, which is 3x, and then 3 times 2, I'm sorry, 3 times, think of that as a negative. Negative 2 would be negative 6. And now, that's a pretty simple form, but we can combine these like terms because both of these end in x. So 2x plus 3x would be 5x. And the rest is just brought down. Keep your pluses and your minus. We can't simplify it any farther than that. So this is a correct algebraic expression. Okay, if you have any questions about lesson 96, let me know.